my name is James Prosser, student number 1008879, and this is from module Human Computer Interface, module code 7MU007. So this is the patch for the BLOX instrument. I'm going to take you through step by step. First of all, I'm going to show you what the patch actually does and how it operates, and then we're going to rebuild that patch step by step, just so we can have an idea of how it works. So this is the patch in its final presentation form. Well, I say final, that's final for the purpose of the presentation. It obviously will be developed in further development process. So first of all, when you open the patch, plug your BLOX into the laptop using the USB cable provided, and then first thing we need to do is select the Arduino. So click on Patcher, that'll open up the sub patch. Then if you're in presentation mode, select print, go on to find it, and then let me just make sure my USB is inserted correctly. Wait for that to load up. So print, go to USB serial 640, then go on to the main patch window, then toggle on to activate all analog inputs, then switch this on. So what that will do is, which we'll get onto further later, what that will do is it will reset the analog inputs so that when you switch on and when you let go, it resets the analog for that. So turn that on, then click 160. Now the purpose of this is so that it sends the delay signal of 160 for the re-triggering of the box as you press the analog sensors on. Then we need to switch on the audio. Okay, and then once that's done, it should be, yep, there we go. So you can see as I activate the sensor pads, it then sounds a bit horrible because we've got none of the we've got none of the scales set. And then obviously if I move the corkscrew, we can see that being utilized there. Okay, so for example, if I was to stick an object in, produce a note, and as I move the cork around, you can see how it's turning up the time of the reverb. It's also turning up the BPM of the delay. It's turning up the band frequency, so it's sweeping between the frequencies, and then as a release, obviously it stops that from going on. So to use the delay, the best way to use it is hold the note on, turn on the delay, press the latch button, and now you have full use of it there. Okay, so that's the instrument. Other things we can do, we have a kill switch which kills the instrument altogether. Then we just switch that back on and it enables us to play with the notes through that. So it's fairly straightforward, really. It's a fairly straightforward patch. There's nothing too complicated. The great thing about the BLOX is you don't have to learn how to use it. It can just be used for a first-time user. It's fairly simple, much like a piano. You put your finger on the note, press down, and it creates a sound. It's not so difficult like a violin, for example, which is a bit more difficult to actually produce a note if you've never encountered one before or had any formal training on that. Okay. So let's go into the patch itself. So we're going to patching mode, turn presenting mode off. So here we have the patch. Now as we can see, when I press a trigger on, we have the output coming here. There's the red X, which just tells me that it's on. We have the numbers going up from 0 to 1, so it's a decimal. Actually it goes 0 to 0.99. We have a slider here which gives us a visual representation of how that is being pressed. Okay, so what's happening there is that's a visual representation of how much pressure is going on the pads. The harder I push it, the higher the pressure, and if I let go, it obviously goes back down to 0. Okay, so to make sense of this, I'll quickly go through it. If we click on this patcher here, there's the UDP receive, which is coming from the information from the main source, the main clock source. So that will be any of the laptop in an ensemble, for example, that might want to send data. So that data is being packed or using a route. So I can have tempo data, and number 1 is giving me data of the scale. So it's an 8-point scale. So then I can route that out to each of my analog inputs. So let's go to number 1, which is over here. So that will be, where is it? Let me just find where number 1 is. Okay, there's number 1. Cool. So that's number 1. So if we go then from the patcher into table store, this was created by Alex Dudley. So this basically unpacks the data, gives us a visual representation of the notes being sent to us, unpacks them, then puts them into the table notes, turns them into MIDI notes, which then gets sent to the output. Now, we've got 1 to 8 through here. So in order for example, my first trigger pad to select number 1, that has to have a 0 message sent into the table store, which will then tell it to choose MIDI note number 1, which in this case is 40. So that will go down into the table store, and then it goes into the patcher here. So we go into this patcher, and there we have a piano roll. So the piano roll just gives us a visual representation of the notes. What we can also do with the piano roll is, if we wanted to extend the range of notes being sent in, so if I go onto the unlocked patch and I create plus 48, for example, so what that will do is it will plus the value of the note by 48, so that we can access a higher range of notes. For example, if I'm only being sent 2, for example, from the MIDI note from the scale, if that's coming through at too much of a lower note, plus 48 will obviously put it up to 49.50, which will then give me a higher note on the spectrum scale. So by doing that, we just simply take the patch off 1, put it into the left inlets, take it out of the main outlets, put it in, and then by pressing the note, excuse me, that will plus the signal by 48. So that's useful, for example, if we want to use it as a standalone instrument, because the output might only be 0, and if the output is only 0, obviously that's going to be too low for the instrument being used. Excuse me. Okay, so going back onto this, we then come out of the patcher into make note 60. Okay, so that will take the number information and turn it into a note. We've also got velocity on the right as well, which I'll get onto in a little second. Into join, into MIDI format, which turns it into MIDI, which then goes into the instrument, which we've got here, the polyphonic drone. However, I have also created ZL group 3 and prepend MIDI evidence, which turns, again, the number into a MIDI event, which you can use it to control any external third-party VST plugins, for example. This is a beep instrument, which can just be directly attached to the outlet of MIDI format. If you're using a VST, use the left outlet of the prepend MIDI event. So that simply goes into the polyphonic drone, polyphonic, so that we can use obviously more than one note, because all the notes are going to be sent to that one instrument. If you had a monophonic instrument, you would have to create a separate instrument for each note, so for each value coming from the trigger pads. So by doing that, you'd have to create a patcher, make note 64N, join MIDI format, and then the instrument itself, and duplicate it across however many trigger pads you have. But we've got polyphonic drone today, so we can have a polyphonic output on that. So set it to latch. Now this latch button is very important, because when you're actually performing your instrument, you can use the latch note to reset the notes. This is important if you're using it as part of an ensemble, for example. So if I play the note, okay, it's a very low note at the moment. If I then press latch, it will reset the note. Now, the reason why it's set to latch and not gated is so if it was gated, it would just send out a bang from the trigger and then immediately stop. Whereas latch will hold on to the notes, basically a sustain. So that then goes into Q1. So Q1 is a third-party plugin that I've used. You can also use the native plugin for Macs. So it's a third-party plugin which is used to control the frequency sweep. So as I'm moving my cork, we can see that that's moving and that's sweeping across. So you can create a sweep effect. That goes into that, which then goes into our delay, which then gets routed into our reverb, which then goes into our output. Simple, really. Now, the reason why we've got multiple outputs is so that we can control the gain of each instrument. Obviously, for patching reasons, this is important because the delay can have a horrible feedback event where obviously the layering of different sounds can obviously create too much of an output, so we can control that through there. Same with the reverb, we've got a live gain switch here so we can control the amount of reverb, and then that all gets sent to the main outputs, which are illustrated here. Okay, now there is another output coming from the polyphonic drone, which goes from the polyphonic drone into another reverb. Now the reason why I have two reverbs, one reverb is being controlled by the cork, which is the petrometer. It's being controlled there, and this reverb is being affected by the amount of velocity that goes onto the pads. So we can see as I put less pressure on the pads, the time itself is less. As I put more pressure, the time goes up. Very straightforward. So it just adds a bit more dynamic to the instrument. And then they get routed to the live gain output, which is also in the presentation mode, which is your main output over here. Okay. So, alright, so where am I? Going back to the original input of the analog inputs, I mentioned earlier that we can analyze what's happening when we add pressure to the pad itself. So we have a visual representation here of how much pressure is being laid onto the pad. That can be used to control a variety of different parameters, such as velocity. So if we go into the patcher again, we can see that inside here, apologies for this. Okay, in here it goes into the right inlet, which is velocity, and into the right outlet, which then gets put through the second inlet on the make note 60, which then comes out of the right outlet, goes into join. So that basically separates the numbers, one to create a MIDI note, one to create the velocity, joins them together, puts them into MIDI format, which creates your MIDI note and the velocity to go with it. So as I push harder on the pad, it will change the velocity of the MIDI note being sent to the instrument. Now, what you can also do, as previously mentioned, pad number one is also set to time of the reverb. So times 99 points, because it's a float number, going into time inlet on the reverb. The reason why it's times 99 is because the number needs to be multiplied in order to reach the amount it needs to make any sort of impact on the time. Then we also have the second trigger pad. There we go. Second trigger pad, which is actually turning the volume down. Okay, so that activates the volume of the main output. And then the rest can also be assigned to different parameters. So if we go back up to our analog inputs, okay, there's one coming from the patcher here, as we can see. Now this is the petrometer. Apologies if I pronounced that wrong. So this is the petrometer, also known as the cork for the BLOX, because we're using a cork as our main control surface for that. So as I turn that down, you can see it goes between 0 and 1. 1 is all the way up, and then all the way to the left is 0. So we can have a visual representation of that here. That's just the slider used for presentation modes to have a visual representation of what's actually happening. So that goes into a float num, which times it by 127, gives us the right output here. Okay, so we can have a visual representation of that. Now, this is being sent at the moment. This is being sent to 3 different parameters. So the first one is the H delay. So the H delay, this is being used to control the BPM. So as I turn that up and turn that down, it changes the BPM. In order to get that to work, going into this patcher, we can see how that works. So the inlets, obviously, from the actual output, the number value being sent from the sensor, or the device, excuse me. Now, there are simpler ways of doing this. This was just an experiment for me because I'm relatively new to Macs. I've organized it so that when it sees a certain number, it will output a bang, which will go to a message, and that message will be sent to the H delay. So the message is 2 space and then the value. So 2 determines the parameter that's being changed and altered. So in this case, number 2 is delay BPM, as we can see here. So that's number 2. Number 1 would be delay sec. Number 3 would be feedback. Then the value of that. So split 0.09 space 0.1 tells the patch that when it sees the numbers between 0.09 and 0.1 to output a bang to the message 2 space 0.1. And it's the same across. So if we go down to here, split 0.04, 0.06, if it sees the number any numbers between 0.04 and 0.06, it will output a bang to the message 2 space 0.004, which then obviously tells the H delay to put the delay at 0.004, for example. So it knows where you're changing. So it's more like a step rather than a sweep as you turn that up and down. So it's the same across the Q and the same across the reverb. Of course, with the reverb, we're selecting time. With the Q, we're doing a filter sweep. So if we go into the reverb, that will now be set to 3 as opposed to set to 2, like it was on the H delay. So if we open that up, okay. Doesn't seem to be. That would be set to 2, excuse me, because it's doing time. So if we open up the patch for the Q, we can see now that that's set to 9. Okay, so that's parameter 9 as opposed to parameter 2, which is on the H delay and the reverb. Oh, and then we've got one more, which is also coming from the same output, which is going into Q1, which is selecting the band frequency. Okay, so it's fairly straightforward. Here we have a bang, which is to turn on the audio, so that switches the audio on and off. That's hooked up to the kill switch, so for presentation mode we can have that toggle on and off. We've got DAC here, DAC tilde, so that we can change the output device if necessary. Important if you're using an external sound device. And then that's about it. That's pretty straightforward. Like I said, there are simpler methods of creating this patch, but for the purpose of experimentation with the blocks, this was the patch I came up with. Okay, thank you for watching. The next video will be on how to create the patch from scratch. We'll be having a go at creating that from scratch. Thank you very much.